So it's exam 75, section 4, questions 1 through 6. Say, okay, are they letting me draw it? And we have a corporation's HR department must determine annual bonuses for 7 employees. K, L, M, and P, and they're in finance. So that's this combination thing. All right, so K, L, M, and P, and they're in finance. So, okay. And B, X, and Z in graphics. Each employee will receive 1,000, 3,000, or 5,000 bonus in accordance with the following conditions. Okay, so they're allowing you to draw it. And it's pretty straightforward. Now, I have a couple choices here, which is, if I want to separate them, I can just do this. I don't have to do that, but when you conflate things, you can get lost. Just like in that last one, if you're conflating the speaker with the topic, it's easier to get lost. So here, if you're going to tell me they're getting, 1,000, 3,000, or 5,000. Okay, well then, I don't have to put them all in the same line. They can, but all right, see what happens. First one, no one in the graphics department receives 1,000. So that's pretty straightforward. Any employee who was rated highly effective, so here's a new variable, this highly effective thing. Anyone who's rated highly effective receives a larger bonus than anyone in his or her department who was not rated highly effective. Okay, so now it's within the department.
Wouldn't it be confusing to have X up there?
Hang on 1 second. Yeah, you're right, yeah. Is greater than effective. Yes, because there's an X.
Yeah.
Yes. So just do that. Not available. So now the second constraint is within each department, if you're highly rated, you make more than somebody who's not highly rated. And the third thing tells us who's highly rated. L, M, and X are highly rated. There we go. And what you're testing now is, how do you build this case? So I would start, for me, my mind would take me down here. Is it fair to say that with respect to the graphic departments, X will receive a $5,000 raise, both V and Y will receive a $3,000 raise? Everybody with me? So again, I'm just trying to divide and conquer, saying, okay, let me get the bottom one. So this is X, and this is V, and that's Z. Everybody okay with that? Then I said, well, let me go to the top one here. Now, just more elasticity in the top one. Is it fair to say that with respect to L and M, they got to get either a $3,000 or a $5,000 raise?
Correct.
Right. So I'm just going to, and they may get the same raise, they may get different raises, but neither one can get a $1,000 raise. So I'm saying, well, how would I do this? I say, all right, so both L and M are here or here. Okay. And then I'm looking, well, who's left? K and P. And is it fair to say both K and P will receive a $1,000 or else a $3,000 raise? They cannot receive a $5,000 raise. And you don't. You know, and what you're testing now is manage. Can you manage this, right? Because you can see what they're going to do. They're going to say up here, you know, like here's not a whole lot they can do, right? But if they say up here, okay, L makes 3,000. Well, if L makes 3,000, K and P have to make 1,000. Right? You know, if they say, well, P makes 3,000. Well, if P makes 3,000, K and M have to make 5,000. There's so little here. So in terms of approachability, do you get this is very approachable? Talk to me. And that's what I want you to be able to, because that could have been the fourth hypothetical. And what you need to be able to look at this and say, I can really be whacking them all on this one. So we could just take one, just to, if I just look here at I would prefer to start off by looking at something generally that must be true, because I just want to make sure I didn't screw up. So if I look at question number 3, right? If only one of the employees receives a $1,000 bonus. All right, well, you know, that's here, right? I mean, you can already see where they're going. If only one receives a $1,000 bonus, then one guy up here is getting a $3,000 bonus, and both of these people are getting $5,000 bonuses. So I don't know where they're going, but okay. So say here, if only one of the employees receives a $1,000 bonus, which of the following must be true? And A says M receives a $5,000 bonus. How's that feel to you? Yeah. You whack them all and you get out of there. You're not looking at B, you're not looking at C, you're not looking at D, you're not looking at E. Does everybody see that? Don't let me trivialize it. Do you guys see it? Yeah, talk to me. Come on, give me something. Don't go quiet on me. I have a long drive back. I don't want to fall asleep at the wheel and then blame you. But I guess I don't have the longest drive in this group.
Without looking at the answer choices, my first thought was either K or P. So it threw me off to see K and P in the answer choices, so like A didn't even occur to me.
Well, we're talking about here in that question number 2, right? Oh, 3, okay. And so 3 says, if only one gets a $1,000 bonus, do you agree it's either K or P?
Yeah.
Well, we don't know which one. Okay, so if you were taking the test, you could do this. If you wanted to be visual, right, you'd say, so that's K or P, which means this has to be K or P, which means this has to be L and M, right?
Mm-hmm.
And then A says, M receives a $5,000 bonus. That must be true.
Makes sense.
Yeah? I don't know if you're still confused or not. I don't, you know, some of this is, you don't want to overthink it. You're brain dead. You're saying, okay, I've set up my law. Now you say to me, well, what's going to happen if just one person gets to 1,000? Then it's inference. It's identical to what we opened the class on, right? That means one of those two got a 3,000. That then means both of the other two had to get 5,000. So it's all what is directly ahead of you, and that's what lawyers get paid to do, is what's ahead of me, not so much what's behind me. Yeah? Are you saying yes to the outside? Is the outside your friend? A little bit? Let's try another one. I want to get some of these. Again, I'm not worried about solving as much as just getting you into, out of your head, whatever was in your head, right? And getting you to approach this the way you will in law school. Let's just do the next one, whatever the next one is. So the next one here would be question 7 through 11. And you just practice this stuff. And they keep repeating it. You go far enough back, you'll find very, very similar hypotheticals to all of this. So 7 through 11, and then this is exempt 75. So a landscaper is going to plant 7 trees. HLMO, let's do that, HLMO. PSW. Okay. Anybody lost yet? Good job.
What do you so
Again,
far?
it's not that tough. I mean, they can make stuff, I don't mean, but it just, if you just practice this, right, and you're disciplined, you'll get it. Okay, so what about these trees? Each tree must be planted on exactly 1 of 3 lots. Okay. Lots 1, 2, and 3, and that's it, in conformity with following requirements. So I'm going to take these 7. Here's lot 1, here's lot 2, here's lot 3. Okay. I can even put a 1, 2, and 3 up here. And each tree is planted exactly once. So would it be fair to say you'd have to be pretty slow to be lost at this point? I mean, not at the end of a 5-hour class, but I mean, okay. Now that's all they wanted me to do. So I can draw it. And now I want to look at the constraints which changed the original law. Do I understand them? And the first constraint is the trees planted on 1 lot are HO and 1 other. So let me put that on the side right now. They're saying 1 lot is HO plus 1. Underline the H and the O. Now, stop for a second. Isn't that an entire lot?
Yes.
So on 1 lot, there are exactly 3 trees, yes? So how many possibilities are there then? Where can, on how many lots can both H and O be planted? Well, but hypothetically.
All
All 3.
Correct. Well, when you say all 3, isn't it fair to say that there are exactly 3 lots on which you can plant HO and there'll be 1 other species? Is that correct?
Yes.
So is it further fair to say that in visualizing this, H and O are either going to be in lot 1, lot 2, or lot 3?
Yes.
And there'll be a 3rd tree there, right? So I have the option, I'm not doing anything right away, but don't I have the option of creating 3 hypotheticals to make a visual? Yeah, talk to me.
Yes.
So I'm not looking at the constraints, but what happens if, think of it, because you want to get into this mode of thinking, right? What would happen if there were a separate constraint? Well, let me not do that. Let's say what we have here. Let's look at the second constraint. M is not planted in the same lot as W. Okay, so M is not with W. So everybody understood that, right? Okay. M, W. Next. Either L or W, but not both, is in lot 1. Okay. So I'm not going to write the not both in there because in my notation, that means L or W. So it means they both can't be there. It would be and or. All right. So does everybody get L or W is in 1? Yes? Talk to me. Okay. All right. See what else we got. We can keep your witnesses here. Next one is either M or O, but not both, is in 2. So that's identical in this language, right? M or O. Now, underline the M and the O. And son of a bitch, they've already both been underlined. Remember, you're thinking about building a case. It's a very, very, very creative section. So, do you see the overlap here? I mean, that's what's coming to my eye. In other words, if we build a hypothetical on the HO constraint, right? So you have H and O in lot 1, then H and O in lot 2, and then H and O in lot 3. Well, I know where O is, right? So you get, when I know where O is, I know M can't be there. In other words, oh, well, we'll see. But the overlap here, I think, is going to be quite helpful. Now, final one is there are more in lot 3 than in lot 1, which is a very common constraint. Okay, so 3 is greater than 1. How many trees are there? And 3 of them are going together in one lot, right? So when those 3 are not in lot 3, there'd have to be 4 trees in lot 3. You're going to say lot 3 has a greater number of trees, right, than lot 1. Well, when the 3 trees together are here, that would require 4 trees to be there. So I'm just saying, okay, all right. Let me now try to put this together. So I have all my witnesses in here, right? And now I decide how I'm going to build this to make a visual. And I'm building it here. All right, so I'm going to create 3 hypotheticals. And we're going to block them off because that's it. So, have we taken, and we didn't get any information here on the P or on the S. Is that correct? So they only gave us information, they gave us 7 trees. But in terms of the witnesses that came in, only 5 of them came. So you built the case on those 5. P and S, I don't know anything about. Right. Now, of the 5, 2 are visual. With me? So now I'm down to 3 that are left. So this I have. And there are so many different ways. Again, there's not just one way to do this. You know, you could look at this and say, well, wait a minute. In this hypothetical, for this to be valid, all 4 remaining trees would have to be here. Right? And you say, well, if I went that way, what would the 4 trees be? So I have H and O. I'd have to have L, M. Well, right, you don't know who that last guy is, right? But I would need to have 4 here. Okay. Let me see what happens. Now, if M or O is 2, and I know where O is all the time, right? Up here, remember, M is one of the ones I want to cite. Is it fair to say that M must be 2 in the top hypothetical? Mm-hmm. Nobody agree? Mm-hmm. There's got to be M. Just want to make it okay. And in the bottom hypothetical, well, either O or M has to be 2, so is it fair to say M has to be 1 or 3? M can't be there, right? Because it's either M or O, yes? So there are a couple of things you can do here. One, you can say, well, that's not M, right? Or the other thing you can do is say M in the second hypothetical is here. So has M become visual?
Yes.
So H, O, and M are now visual. Okay. M is not with W. So is it fair to say that in the top hypothetical, W is either at 1 or 3?
Mhm.
And the bottom hypothetical, I'm just going to note over here, I'm going to erase this in here, just get in
Wait 1 second, please.
the way.
Wait 1 second. I can study later. Thank you.
Look,
Yes.
I'm just going to erase this one, because I have it up there, the 3 is greater than 1. So here, and here, okay. Now down here, when you have M or O is in the second slot, who's got to be down here?
Yeah.
M. Need this now. Okay, so let me see if I can figure out what I've done with M. So in the third hypothetical, I placed M, right? And in the second hypothetical, I have M at either first or third. And in the top hypothetical, I placed M because it had to be M or O in the second lot, right? Yeah, talk to me. So I'm looking at what's visual now, and H, O, and M are precisely visual. With respect to W, well, the W just can't be with the M, right? So up here, yeah, I got to move the W around, right? But the W's just not with the M. Down here, the W's just not with the M, so that's on the side. Okay. And so it's this. And now I have L or W in one. Okay. So then I would just have this as and that's it. And what I have left are P and S, which have to be managed, right? So over here, would it be fair to say that this has more involved than the one we did immediately before? And that this bears greater similarity to that second one we did, right? And that's the way it's going to be on your test. Remember, they got to get a 14 out of this, right? So you don't get a 14 out of this by giving two of them up right away. So now with this, and let me just go back to this top one. If that has to be L or does, that's 1, 2, 3, 4, yes?
Can't work.
Right, so this whole thing's invalid. But it's requiring you to, again, deliberate. You get that if they want to ask you which of the following must be false, right here, it must be false that 3 trees are planted up here, that that H and O are planted in lot 1. That must be false. Do you see it? So what you end up managing now are only the bottom 2. But if you didn't see that, now you'd be working with 3 hypotheticals where only 2 of them were valid. And this is very common. They let you build it, right? But what you built was invalid. So that they can turn around and say, okay, well, now we're going to ask you what must be false. So, but now it becomes a hell of a lot easier to, you know, you say, oh, you mean I can get rid of this? Yeah, I can get rid of this. Get rid of all this. Terrible board. Okay, and now I'm down here and saying, so what's left? Okay. I see the M, here I have, fine, let me just see if I can manage this now. And so I like the looks, again, what I would be doing is I'm always skipping over the first question. That's the orientation question. You don't have to do anything to get that right except apply the rules to it. So it doesn't require anything creative. You can get that right. So if you're running out of time, you want to do the first question because all you do is apply the rules and then eliminate choices. But here, if I look at question number 8, it says, well, if hickory is planted on lot 2, so didn't they just send me right here? And then they say, if hickory, then which one of the following trees must be planted on lot 3? Okay. And actually, yeah, we missed this deduction. A says the L, and that's no. And B says maple, and the answer is, yeah, maple's got to be here. Right. So this maple, because we've abridged it. I wish they just had a regular eraser. Because the maple comes down and falls here. So B says the maple, which it is. C says the plum, which plum doesn't have to be there. The plum can be right there. D says the sycamore, which can be right there. And E says the walnut, which is going to be either there or actually probably be there, but it's there or there. Yes, no, not voting?
Question, do you always build multiple hypotheses, or just often? Or?
Often.
Uh-huh.
Often. It is, well, again, when you don't need to visualize, you don't do it. What's going to happen as you practice this is you're going to need to visualize less and less. So for me, as I started, I'm saying, well, let's maximize visualization, right? And when you don't need to do it, for God's sakes, don't do it. So there are some of these, you can put the constraints on the side and work right from the constraints. Some of these are not, just most of these are not designed for that. Again, because the way the test is structured is, I need to slow you down even if I'm going to let you get them right. Because I've got to get 14 as my median score.
Also, Jim showed us a nifty trick where he, as he's going through the rules for the first time, uses it to answer the orientation question.
Oh no, that's what we
Is
would
that-
do, sure.
Okay.
Yeah, I'm purposely skipping that.
Okay.
Because that's exactly right.
Okay.
That requires 0.
Yeah.
Skip. Right. The way you answer every orientation question is simply say, here's a rule, let me apply it to each of the answer choices, and it will eliminate one or more answer choices, whatever's left is the answer. Yeah. Yeah. The creative part is what you can't do that. Yeah. But again, this is stuff. Just try. We have time yet. I can just at least put one more up to organize it. And all this is on video. Everything I'm doing here is on video. So, because I'm trying to rush through it here just to make examples.
And this one will be up on Tuesday, right?
That's up now. If you go to the analytical library, that's there. That's there
Okay.
24/7. Yeah.
Okay, and how would I find that? What class would this be?
That would be when you go in for classes I'm registered for.
Right.
You'll be registered for this class, and you'll also be registered for the analytical library. So all you do is click on the analytical library, and that's going to take you to all this where it's all done. Yeah. But here, it just gets rushed because there's no time.
Hey, there's always time. We always have time,
Well,
right? We have more than enough time, rather.
on the test, but not in class, unfortunately. So let me just try to, again, just get one that's approachable here, not go crazy. Okay. So this is so we moved ahead here to this is exam 77. So this, again, is the last exam I want you to work on. Don't go ahead of this.